Hi everyone, I'm Bitianzhi from Alibaba Damo Academy. Here's my presentation. The name of the paper is Constraint Translation Candidates, a bridge between neural query translation and cross-lingual information retrieval. As we know, in cross-lingual information retrieval, there are several problems that affect the quality of retrieval. Firstly, the language between buyers and sellers are different. For example, in the scenario of AliExpress, the buyer may come from Russia and the product he wants to buy is sold by Chinese. Secondly, due to the query is multilingual, cross-lingual information retrieval usually translates it to language of search index for the downstream retrieval. So if translation error occurs, buyer will fail to see products which are related to their intents. Thirdly, considering that sellers are also from all over the world, so the title and the detailed information of products are written by English. In cross-lingual information retrieval, we will translate query and title into the same language. Because of different distribution of query and title, we deploy different systems for each of them that will introduce inconsistency of the same word in query and title. Here is the example of mistranslation affect shopping experience. The buyer wants to buy iWatch but gets the product of iWatch. As we mentioned before, inconsistency of the same word in query and title will also miss what buyers really want. In this picture, consumer is planning to search beach umbrella, but we offer him beach sunshade. However, both of sunshade and umbrella has the same effect, but the consumer may run a store and intend to provide tourists a place to drink and eat. Now, I will introduce our work about how to alleviate mentioned problems above. Here is the overall architecture. We divide our work into two parts. In training process, similar to normal label smoothing, we let golden words has label alpha, and the candidates share 1 minus alpha equally. Candidates are obtained by querying database using source words. In next slides, we will introduce how to build a database of candidates. The purpose of this process is to make model pay more attention on target words which related to source words. But in fact, if we set the label of all the other words except golden and candidates to 0, model cannot learn the differences among golden words, candidates, and true negative words. So we combine golden MLE and L alpha with interpolation, which not only distinguish golden and true negative words, but also pay attention on the distribution of the target words that related to source words. In inference process, we first query the database of candidates and get all the words that related to source words. In beam search, we mask all the words in vocabulary except candidates and calculate softmax on candidates like formula below the picture. In this way, the translation model merely calculates the prediction distribution on the constraint translation candidates, thus generating more related tokens for the subsequent task. The benefit of candidates is offering a bridge between translation and information retrieval, so the quality of candidate database is a key factor of our work. In these slides, we introduce how to build constraint candidates. Given a source word xi in user query x, we first obtain a set of its possible target tokens yi with its translation probability distribution in bilingual training corpus. The process can be achieved by a statistical word alignment tool. The candidates yi can be continually scored and filtered according to the distribution of target terms in the entries clicked by users. Users across the world issue multilingual queries to the search engines of our website every day, which form large-scale cross-lingual click-through data. Intuitively, when a recall item leads the user to click details and even make purchase, we attribute the target tokens in terms satisfy the expectation of users. With the help of such an automatic and low-cost quality estimation approach, our model can acquire high-quality in-domain translation candidates derived from documents and user behaviors. From the click-through data, we first extract all the documents DXI that users clicked with any queries contain XI. Thus, we can use TF-IDF score to identify the importance of each translation candidate in YI and sort them to get VI. In experiments, firstly, we evaluate the impact of different constraint size on the Russian to English translation tasks. With the increase of the constraint size, our method consistently improves the translation quality. The result demonstrates that a small set of constraint translation may miss some of important vocabularies, weakening the generation ability of the model. The larger constraint size offers a flexible manner to select predictions, thus yields better performance. However, when the size rises to 20, the translation quality reduces. We attribute this to the fact that unrelated candidates makes error propagation from TF-IDF or word alignment, and leads to decline of translation quality. In Table 2, our neural machine translation baseline significantly outputs the SMT model on such kind of phrase-level text translation task, which makes the evaluation convincing. The results also confirm that the Neural Query Translation model surpasses its SMT counterpart. As seen, the proposed model yields higher BLEU score than the strong baseline system, revealing the effectiveness of our methods to improve the translation quality of query translation. Secondly, we examined the retrieval accuracy of 1,612 search queries in 21,906 documents. The experimental results are concluded in Table 3. Obviously, on both of recall, MAP, and NDCGR10 indicators, our model consistently surpassed the baseline transformer model. The results confirm our hypothesis that forcing the query translation model to generate search-aware tokens benefits the retrieval task. In Table 4, we show some good case out by our proposed model. In this paper, we first tackle the problem of mismatch between translation and cross-lingual information retrieval. We use word align and TF-IDF to build candidates which improve quality of retrieval. And in future, we will focus on how to update the constraint candidates more effectively. In future, we will focus on how to update the constraint candidates more efficiently and explore different methods of building candidates. Thank you.